Hey everyone, welcome to Dr. Frank's Finance World. I am Dr. Frank the Bank because I try to teach you something about finance and you can make a little money on it in the future. Please subscribe and get notifications if you would. Look in the notes for links and websites. And today's stuff we'll be discussing is risk and return, a pretty common topic inside of corporate finance. So there are two types of standalone risk, if you will, or two types of risk. You could have standalone risk for the firm itself, or you could actually have portfolio risk, and you'll have to deal with both of them in any type of intro to a corporate finance class. But investment risk is related to the probability of earning a low or negative return. Isn't it funny? They don't talk about how much money you could make, but how much money you might lose, because people are kind of risk averse. That actually makes sense. The greater the chance of a lower than expected return or negative returns, the riskier the investment. Ask anybody out there that suffered through 2022, they'll tell you that's true. And another part of it that's actually kind of interesting is this idea of risk metrics as part of the empirical rule. Many times people have done this in classes out there and stuff like that, business stats classes and so forth, but they haven't really applied it, and that's an important part of what's going on here too. So ultimately, we do have the risk and return. Part one is to look at the probability distributions. This is where we expect things to happen, where we expect the average returns to be. In any normal distribution out here, the peak of the distribution is actually where the expected return would be. In this case, it's 15% out there, but a list of all possible outcomes is what stretches it from one end to the other. Now, the interesting thing about this one, firm X and firm Y, is that they both have the same expected return, but you can see that firm Y has a much flatter distribution, and that means the standard deviation is bigger, and you will end up with more observations that are further away, and maybe more particularly, you'll end up with more observations that are in the negative return. So Y would be seen as a more risky distribution out there or investment. How do you actually calculate that? Well, in this case, we're looking at a company called High Tech out here, and we're looking at the observations of different possibilities of the economy. Remember, they all have to add up to 1.0 when it's all said and done. But ultimately, if there's a recession in a high-tech firm, indeed you do tend to lose money, and they're showing an expected negative return for that observation. A below average and an average above, and boom, you can see this is a equal distribution here, equal probability centered around the average of 12.5%. But the returns are not equal. You know, of course, a bad year, you would lose 29%, but that's one of the reasons people like to be in high-tech stocks, is when the going gets good, it gets good. And you make 42.5. So how do you figure out the peak of that distribution? You actually take the probability times the outcome all the way down. And you just keep doing that. And this becomes a component value over here. And when you add them all up, you end up with the expected return. We'll see that again in another example coming down here. But if you took the 0.1 and multiplied it by the 29.5, you get this outcome. If you took the 0.2 and multiplied by the 9.5, you get this one and so forth. And by the time you multiply them all across and add them up together, you get an expected return of this portfolio of just under 10%, 9.9%. So the mean, of course, is the peak. The expected return is the peak of the normal distribution out there. To find the points on the normal curve, in other words, the empirical rule will give you a distribution to lay it on, but you have to find the points at the bottom. And it doesn't matter. We'll see in examples at the end here, whether we're talking about stock returns, we're talking about toilet paper sales, or you're talking about, anything else out there that you can apply it, fill rates for bottles or failure rates for computer chips. All of it is part of this process of putting the distribution on top of some expected number out there. So to find how flat that curve is, to find the variance out there, you need the standard deviation, and you have to get it through variance. You can't go to standard deviation directly. I know it looks like you can when you do it in Yahoo Finance, Excel and Yahoo Excel there. But ultimately, it's you have to find the variance through. They make it look harder than it really is. they get this really scary looking equation over here and all the rest. But what it really is, it is the actual observation minus the expected observation squared to find out the distance away it is from the middle of the distribution and so forth. You have square the negative ones, or that would look weird, but and times the probability out there. So it's the actual minus expected squared times the probability. And when you sum them all up, you have the variance. And when you take the square root of the variance, you have the standard deviation. So that's all that we're doing here. Let's see an example of that. So if we went back to high tech, what we had before, we realized that the expected return was 9.9%. And we take each of the actual observations. In the first case, there was a 10% chance that you would lose 29.5% of your money. So you take minus 29 minus 9.9 because that point is way over here. It's over in this part of the distribution and so forth. But at any rate, you square it and multiply by the probability. The next observation, which was a not great economy but not a recession, had you losing 9.95 or 9.5%. When you take that and subtract the actual minus the expected squared, and that's what the 2 is supposed to be there, squared, and then you multiply that probability was 20%, and you take the middle of the distribution, the actual minus the expected squared, times the probability and so forth. When you add all these up, you actually get a variance of 400%, which sounds like a lot, but by the time you take it to the 1/2 power, you have a standard deviation of 20%. Now what's going to happen is it's going to line up on this 9.9%, and you're going to be starting to subtract 20% away once and then twice to figure out where the data points are on the losses over here. But that's how you go through and do these type of problems. Keep in mind, standard deviation measures total or standalone risk. The larger it is, the lower the probability that actual returns will be close. And that's a problem when you're talking about losses, because the actual returns will be further away and therefore bigger losses. A larger standard deviation is associated with wider probability of the distribution returns, or that flatter curve as we saw for firm Y earlier. So the ability to apply the empirical rule is the power of statistics. You probably hated the stats class out there or something that was talking about confidence intervals and so forth, but you're actually just laying things on top of this type of a distribution and then saying what the data points are down below. So in this case, 9.9% was the mean we were looking up here. So we take 9.9% and we subtract one standard deviation, and we know that 68% of the time those observations will lay plus or minus one standard deviation. So you'll add one, subtract one. When you subtract one, this is essentially 10%. This point will be about minus 10%. When you subtract another 20%, you will have this point being about minus 30%, and this will be about minus 0.50%. So you figure out where the points are on the lines by doing this process over here. And it actually allows you to say something about whether that is a rare observation or not. Last year, at one point in time, the NASDAQ in 2022 was down about 35%. And what you're actually showing is that was probably a point somewhere over in here. And given that you only have 2.5% of the observations this way and 2.5% of the observations this way, it's a pretty rare point that you would have lost 35% in 1 year. So thus 32% of the time the stock will lose more than 11% or gain more than 29%. Half of the time, this is for one standard deviation, half of the time it will lose and half the time it will gain. So you have a 16% chance you will lose more than 10% on your money. So there will be more problems to practice this at the end of the whole risk and return part. The standard deviation is just one way to look at risk. Keep that in mind. Another is to compare how the stock moves relative to the market, and that is called CAPM, Capital Asset Pricing Model, which of course is what part 2 is about. So be sure to send us comments out there, Dr. Frank's Finance World at JBA Wealth or F. Smith at JBA Wealth. I hope this helped a little bit, and let's move on to part 2. Have a great day. Bye-bye.